Dear students of class 9, welcome to you all in higher mathematics class. I am Sudipan Bhattacharya with you. So today we are going to learn about infinite series, and this is lecture 4. Lecture 4 on infinite series. Those of you who have not taken part in the first 3 lectures, please go to those lectures, take part or watch the lectures carefully, try to understand them, and then come to this lecture, and then you will be able to understand the topics of this lecture today. So today we are going to learn about some special thing. So what is our objective today? Today our objective is to learn the partial sum of the partial sum of the series like 1 plus 11 plus 111 plus 1111, like this. So our objective is to find out the partial sum of the series like 1 plus 11 plus 111 1111, like this. So you can make another series like 2 plus 22 plus 222, like this. Or you can say another series like 7 plus 77 plus 777, like this. You can build up this kind of series using any of the digits 1, 2, 3 up to 9. So these are very special kind of series, and all of these series are divergent series. So we cannot find the infinite sum of this series, but we can find out sum up to n terms, like up to 100 terms, up to 1000 terms, or up to n terms. N terms means we can build up a formula which will give us the partial sum, or which will give us up to any finite term, like 100 terms, like 1000 terms. We can give a formula like this. So we will find out the sum of first n terms. Sum of first n terms means sum of first n terms, which is shortly called partial sum. So we will find out the partial sum of this kind of series. We will learn how to solve this exercise. Now suppose that you are given a series like this. You are given a series like this: 2 plus 22 plus 222 plus dot dot dot, and you are told that find out the sum of first n terms. First n terms of the given series. Now you are told to find out the sum of first n terms of the given series, or you might be told like this. Instead of first n terms, you might be told like this: partial sum of the series. Or you might be told like this: formula for partial sum. Find out the formula. Find out the formula for partial sum of the given series. So you might be told asked like this. So what you have to do is you have to find out the sum of first n terms of the given series. This is the objective. You will learn how to find out the partial sum or find out the formula of sum of first n terms of the series. Now to solve this, if you see one solution, we can solve any this kind of problem. So I will give you just an example and try to understand it by seeing only once, because this is very easy. So suppose that and the sum of first n terms of the series is Sn, where supposing that the sum of first n terms of the series is Sn. Now what does Sn means? Sn means Sn equal to 2 plus 22 plus 222 plus nth term. We don't know what nth term is, but we know that it will be repeating n times, 2 n times. So Sn equal to this series. If we now what we have to do is make this series like 1 plus 11 plus 111 like this. So our target is to make this series like 1 plus 11 plus 111 like this. So to do this, we have to divide this series by 2. So we have to divide both sides by 2. So we can write Sn by 2 equal to 2 plus 2. Sorry, Sn by 2 is equal to 1 plus 11 plus 111 plus like this plus nth term. Nth term will be what here? Nth term will be 1 1 1 1 1 repeating n times. So we cannot write this up to n times, so I will write this only nth term. So if we have got this, now we are going to turn it like this: 9Sn by 2. We are going to make this the series like 9 plus 99 plus 999 like this. So for this we will multiply the series with 9. If we multiply the series with 9, then we have to multiply 9 with left side also. So multiplying 9 in both sides, we will get 9 plus 99 plus 999 plus nth. In nth term, what we will get here? In nth term, we will get 9s, n number of repeating 9s, 9999, like this, n 9s. So I cannot write n 9s here, so I have just written nth term, whatever nth term is, 9 plus 99 plus 999. So nth term will be like 99999 up to n terms, n 9s. So what we have done in these 3 steps is, first we have taken this series, this sum as Sn. Then we have converted this sum is in the form like 1 plus 11 plus 111 like this, and then multiplying by 9 we have converted the series. We have converted the series in the form of 9 plus 99 plus 999 plus whatever nth term. For all of this kind of series, our target is this line, 9 plus 99 plus 999. This line is the we have to convert all of this series in this form by multiplying and dividing. If the series 9 plus 999 plus 999 is given, then you don't have to do these 2 parts. You don't have to divide it by 9 and then multiply it by 9. So now what we am going to do is 9Sn by 2 equal to, we can make write this 9 by 9 minus 1, sorry, 10 minus 1 plus, we can write it like 100 minus 1 plus 1000 minus 1 and so on up to nth term. In the nth term, what we will get? In the nth term, we will get, in the nth term here, what we will get? So let us see what we will get, which is equal to, you can say 10 minus 1 plus 10 square, 100 means 10 square minus 1 plus 10 cube minus 1 plus what we will get is 10 to the power 10 minus 1. We can see at the first term we have only one 10 square, so power of 10 is 1 here. At the second term, power of 10 is 2 and minus 1. At the third term, power of 10 is 3 minus 1. So at the nth term it will be power of 10 will be n, then minus 1. So now from now on we will not be writing nth term. So because we can write nth term in short here. So what is it? We can write that 9Sn by 2 equal to, we will say odd here. What you will get is, now if we split the terms 10 to the power 1, 10 square, 10 cube, they all are added, and from each term minus 1 is subtracted. So if for each term we will get, for each term we will get a power of 10 like this. Taking only the tens, we will get 10 to the power 1 plus 10 to the power 2 plus 10 to the power 3 plus up to 10 to the power n. We will get from all the terms here, if we take the power of tens, then we will get this series 10 plus 10 square plus 10 cube plus 10 to the power n. And for n terms we will get minus 1 here, minus 1 here, minus 1 here. So we will get minus n number of 1, or we can say just minus n into 1, because from here we will get 1, here we will get 1, here we will get 1. So if there are 4 terms, we will get 4 ones. If there are 5 terms, we will get 5 ones. Here there are n terms here, so we will get n number of ones, therefore n into 1. So now you can see that in the first bracket here, we have got a geometry series in which the first term is 10, and in each term 10 is multiplied. So here a is equal to 10 and r is equal to also 10. This is a geometric series where first term a is equal to 10 and r is equal to 10. So we'll write this like this. We'll write it like this. In the series, I will make it 1 by equation 1. In equation 1, the series within first bracket is a what type of series? Geometric series, where first term is a equal to 10 and common ratio is r equal to what? 10. So we can say that this is this portion is a geometric series. So we can say that therefore sum of the series is sum of the series geometric series we can say that not geometric series, we can say it is a finite geometric series. In sum of the finite or sum of the n terms of the geometric series is equal to what? A into r to the power n minus 1 divided by r minus 1. Why? Since r is equal to 10 which is greater than 1. R is equal to 10 which is greater than 1. Therefore, we can say this. R equal to, we can say 10 into 10 minus 1, 10 to the power n minus 1 into the power n minus 1 divided by value of r is 10 minus 1 which is equal to 10 by 9 into 10 to the power n minus 1. Now this is the sum of sum of the n terms of the geometry series which is in the first bracket. So now you can say therefore equation 1 becomes 9 into Sn by 2 equal to what? In second bracket you have 10 in second bracket you have the geometric series. So in second bracket we will put in first bracket we put like this 10 to the power 10 by 9 10 to the power n minus 1 and here you have n into 1, therefore we can write it minus n. So you can see here for this series geometric series 10 plus 10 square plus 10 cube plus 10 to the power n. The sum is, what is the sum? The sum is 10 by 9 into 10 to the power n minus 1 and for n into 1 we will have n. So it's like this. So we can opt out, we can put the, we can remove the second bracket here. So this is what is no use now. No, but use this second bracket. You can use that. So 9 by 2 Sn equal to 10 by 9 into minus n minus 1. So what is the value of Sn? Sn equal to 2 by 9 into 10 by 9 to 10 to the power n minus 1 minus n. Right, like this. And now you can write 20 by 81 into 10 to the power n minus 1 minus twice n by 9. This is the value of this. So Sn equal to 20 by 81, 10 to the power n minus 1 minus twice n by 9. So this is the sum of first n terms of the differences. I think you can understand this math. This is very easy. All the maths are same times, same types. So I think it will be you will find this very easy. So for revision, I will only do another math, so that you can understand. So suppose you are given that problem, that find out a formula to calculate the partial sum of the following series. And the series is given by 8 plus 88 plus 888 plus 8888 and so on. So we have to find out a formula to calculate the partial sum. Partial sum means the sum up to n terms of any infinite series. So this is an infinite series. We have to find out the sum of n terms, first n terms. So what will be the solution? Let the sum of first n terms of the given series be Sn. Then Sn equal to 8 plus 88 plus 888 and so on up to nth term. Or Sn by 8. We have to make it 1 plus 1 1 plus 1 like this. So dividing both sides by 8, we will get 1 plus 11 plus 111 plus nth term. are making it, we are going to make it 9 plus 99 like this. So we will multiply this 9 by 8, multiplying the 9 plus 99 plus 999 plus now what we are going to do is or 9sm by 8 equal to 10 minus 1 plus 100 minus 1 plus 1000 minus 1 plus nth term. So which is we can say which is 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 plus at the nth term we will get 10 to the power n minus 1. So or we can say 9sm by 8 equal to splitting this 10 power of 10s and minus 1, we will write 10 plus 10 square plus 10 cube plus this will be a series up to 10 to the power n into 10 to the power n. We will get this series, and then minus for 1 1 1 2 1 3 1 this like as n ones will be there. So n is here, n into n number of ones will be deducted from first term. There will be 1 deducted, 1 will be deducted, second term 1 will be deducted, for third term n will be deducted from the third term. So from each of the n terms 1 will be deducted. So for n terms n will be deducted. Now you can say, now we can make it equation 1. Now 10 plus 10 square plus 10 cube plus 10 to the power n is a finite geometric series where first term a equal to 10 and common ratio r is equal to 10, which is greater than 1. Therefore sum of n terms of the geometry series equal to a r to the power n minus 1 divided by r minus 1, or 10 plus 10 square plus 10 cube plus 10 to the power m. This is the sum of n terms of the series, which is 10 into 10 to the power m minus 1 divided by 10 minus 1. Putting the value of a and r, we have got this. So we can say that it is 10 by 9 into 10 to the power n minus 1. Now, therefore, 9 Sn by 8 is equal to 10 by 9 into 10 to the power n minus 1 minus 8. So, or Sn equal to 8 by 9 into 10 by 9 into 10 to the power n minus 1 minus 8. Or you can say Sn equal to 80 by 81 10 to the power n minus 1 minus 8n by 9. So this is the answer. So for MCQ, you can memorize that. For MCQ, you can memorize that. For MCQ, repeating digit series like a plus b plus a. This is that a is might be. It is not actually like this. It is like 10a plus a. This is like 100a plus 10a plus a. Like this. So if we write it like this, then we get this repeating digit series. Now repeating digit series means for this type of series you will get Sn equal to, look at here, 8 was here and remaining parts is same. So a by 9 into 10 by 9 into the power n minus 1. A, the digit is at the numerator by 9, a by 9. The second bracket is at 10 by 9 into the power n minus 1 minus 1. Or 10 a by 9 10 to the power n minus 1. So 10 by 9 square, 10 by 81, 10 by 81, 10 by this one, 10 into a by. So this is the, for MCQ, this is the formula for sum of the n times. Now if we were asked that what is the sum of first 30 terms of the series 5 plus 55 plus 555 plus like this, your answer will be like this: 5 by 9, 10 by 9 into 10 to the power n minus 1 minus n. So minus n. So here the value of n is 30. So erase this n and put there 30. So put here 30, which will be the answer. Or you can write it like this: 50 by 81 10 to the power 30 minus 1 minus 150 by 9. You can say 50 by 3 like this. So this is the answer. Or you can say 50 by 3. 50. So this is the answer. You can write it for this instance. So I think you have understood this kind of problem, and you will be able to solve this kind of problem. Now homework. For your homework, build up series like this using digits 1 to 10, 1 to 9. Build up series like this, and find the final sum or partial sum or sum up to and stuff, or sum of first 10 terms. All are the same thing. You have to build up the series like 1 plus 11 plus 111 plus total, or using 2, you build up 2 plus 22 plus 222 2000. For 3, you will build up same kind of series, and then you have to find the partial sums of the series. In which method? Must not in MCQ method. What I have told you, not MCQ. This is not MCQ. You have to find out the sum of first 10 terms or whatever it is. You have to use the or you have to solve it in detail. In detail. So this is your homework. So see you in the next class. Till then, keep well and keep practicing. Thank you.